Ensuring access to safe and sustainable sanitation is one of the most urgent global challenges. Despite notable progress, billions of people still lack adequate sanitation services. To tackle this issue, Sustainable Development Goal 6 was established. It aims to ensure the availability and sustainable management of water and sanitation for all by 2030. To support this mission, a novel tool has been developed, Hashemi's Sanitation Sustainability Index. The HSSI is a community-based indicator designed to assess the sustainability of sanitation systems before implementation. It comprises 3 sub-indices: technical, economic, and social. Each sub-index includes dimensionless variables that are normalized to reflect the specific conditions of the community, ensuring that the index remains flexible, scalable, and context-sensitive. The technical sub-index assesses 3 primary variables. Water efficiency measures the water used per sanitation event against the community norm. Energy efficiency evaluates the energy needed for wastewater treatment, and water recycling efficiency determines the proportion of waste that is safely recycled and reused. These variables were calculated using straightforward equations that compared the proposed system with existing community standards, enabling meaningful comparisons between different technologies. The economic sub-index comprises the capital cost index, maintenance cost index, and direct economic benefits. These variables evaluate the financial feasibility of sanitation systems. Systems that are cost-effective or capable of generating economic value, such as fertilizer production, receive more favorable scores. This sub-index is particularly valuable for assessing sanitation systems in low-income or resource-constrained settings, where affordability is crucial. The social sub-index examines acceptability, which considers how well a system aligns with cultural norms and user preferences. The public health impact assesses a system's effectiveness in promoting hygiene and reducing disease. These variables are evaluated through local surveys and pilot studies. Although qualitative, they are converted into dimensionless scores to ensure consistency and comparability. To illustrate the HSSI's applicability, 2 sanitation systems, a conventional septic tank system and a resource-oriented sanitation system, were evaluated in a suburban area of Seoul, South Korea. The ROS system achieved a higher HSSI score of 0.71 compared to 0.42 for the septic tank. This was primarily due to its superior performance in waste recycling and its potential for economic benefits, despite being less socially acceptable. Monte Carlo simulations were employed to forecast the statistical distribution of the HSSI scores, confirming the index's reliability. The calculated values fell within a 95% confidence interval. The HSSI is designed to be adaptable to various regions and timeframes. It can be applied to rural villages, urban slums, or even national level planning, provided that local data are available. Its simplicity, flexibility, and focus on pre-implementation evaluation make it a valuable tool for policymakers, engineers, and development agencies. Hashemi's Sanitation Sustainability Index offers a structured, evidence-based approach to selecting the most sustainable sanitation systems. By integrating technical, economic, and social dimensions, it supports informed decision-making and contributes to the global goal of universal sanitation access worldwide.